Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of smart people there. Sorry, I don't know what's going on with my tongue. Um, Today's puzzle is called One's a Crowd by PhoenixAki, and I'm doing the challenge mode, which is there are two different versions, and I think PhoenixAki originally published the other version first, but you didn't actually have to go about the path that he was sort of thinking, or they were sort of thinking. I don't know if it's a he or she, when they created the puzzle. So then they created this challenge version, which sort of forces you to go down this path, just to make sure. Because otherwise you would just be able to solve it with the normal Sudoku methods, and I think he's thinking that it's probably a little too easy then if you do that. Anyways, let's get to the rules. We have normal Sudoku rules apply, where we need to place the digits 1 through 9 in each row, column, and 3x3 box without repetition. We have arrows, where digits on an arrow must sum to the digit placed in that arrow's circle. Digits may repeat on an arrow if allowed by other rules. Note, in this challenge mode versions, all arrows are visible from the start. So that means we know that these are all the arrows that we have. And that's important because we have this rule set, which is all but one, where all arrows except one contain at least one 1, and all ones except one appear on arrows. Interesting. So, all arrows contain at least one 1 except for one arrow, and all ones except for one must appear on arrows. As an example of an arrow, say we had 3 and 4 here, then this would have to be 7 because these digits must add up to the digit in the arrow's circle. And we know all the arrows contain a 1 except for one arrow. And we know all the ones are on arrows except for 1 1. So keep that in mind. We also have crop key pairs, where digits separated by a black dot must have one digit be double the other, that is a 2-to-1 ratio, and digits separated by a white dot must be consecutive. So, for example, if this were, say, a 2, this would have to be 1 or 4 to maintain the 1-to-2 ratio between them. And if this were, say, a 6 here, this would have to be 5 or 7, because these digits must be consecutive, because there's a white dot between them. And finally, we have killer cages, where digits in dotted line cages must sum to the number in the top left corner of the cage, and digits may not repeat within a cage. So far we only see 2 digits here, which now add up to 16. We could have an extended version of this cage, which actually adds up to 16 also. We just don't know where this cage is, and I guess that's part of the challenge version. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So this digit is the sum of 3 unique digits, and it cannot be 9. So this is 6, 7, or 8, because at minimum you have 1, 2, and 3 adding up to that digit. These digits are at minimum 1 and 2. And so we are guaranteed a 1 here. That's interesting. So we're going to mark those as blue. So 1 has to be on that arrow, which means 1 cannot be here. This is at most 8. These 5 digits by themselves must add up to 15. And with another digit, they must add up to 16. So this can never be 6 here. So if they could be 8 and 8. And that would be possible, which would be 1 being there. So this is adding up to 15 here. We could have 8 and 9 here. So therefore, this is 1 or 2 at maximum. This digit has to be the sum of at least 1, 2 and 1, 2, which adds up to 6. So this is all 6, 7, or 8 also. This has to be then, it cannot be 7 because 7 and 8 only add up to 15, and these arrows must add up to at least 16. So this is 8 or 9 here. These arrows must add up to 1, 2, and 1, 2 at minimum. So this is 6 through 9 there. Okay. We are guaranteed a 1 here. We don't know if we have a 1 here. So this could be the arrow that does not have a 1. This, I think, has to have a 1. What if we try to have no 1 on this line? It would be 2, 3 plus 2, 3. So there has to be a 1 here in one of these, at least. And it could be in both. Interesting. Okay. Where is 1 not on an arrow? If this does not have a 1, if this does not have a 1, obviously there has to be a 1 on this arrow. Or 1, sorry, the 1 cannot be on an arrow in this box. We know this has to have a 1. Does it have to have 1 in both? I think so, actually. Well, it could be... Yes, it has to have a 1 in both of these. Because if you try to have a 2, 3 with 1... Well, you could have 8. Okay, what happens if 1... So 1 is guaranteed to be on this arrow. We don't know if 1's guaranteed to be on this arrow. So what happens if 1 is not on this arrow here? That means box 9, the 1 cannot appear on an arrow. Therefore, the rest of the boxes must have 1s appearing on the arrows there. Well, what happens if 1 is not on the arrow here? In box 8, 1 cannot appear on the arrow. And therefore, 1s have to be in the rest of the boxes. What about if 1 is not here? If 1 is not here, that means 1 cannot appear. Oh. 1 cannot appear on this arrow here, which means in box 7, 1 is not on an arrow, which means in all the rest of the boxes, 1 has to be in that, on those arrows. What if this were not 1? If this were not 1 here... But the thing is, okay, so what happens if 1 is not on this arrow? That means you have to have 1 here, and 1 here all on this arrow, but that would guarantee 1 here and 1 here when we know we have a guaranteed 1 in box 6 in one of these 3 cells. So 1 has to appear on this arrow also. So this is guaranteed to have a 1. If this doesn't have a 1, that means box 3 would not have a 1 available in it. Actually, that's also problematic in that if box 3 would not have a 1, but box 1, would not have a 1 on the arrow. Box 4 would have to have a 1 on the arrow here, and box 5 would have to have a 1 on arrow here, and that would be not possible. So 1 has to appear on this box. So that means we are guaranteed we must have a 1 here, and we must have a 1 here in these boxes here. So where's 1 in row 1? It can only be here. So this is 1, which means this cannot be 1 here. Where is 1 in row 2? It has to be here now, which means that's 1, which means this can't be 1 here, which means we need a 1 in box 1, because again, anytime you have a 1 missing on the arrow, it has to be missing not on an arrow in those boxes, which means ones have to be the arrow in the ones which have an arrow there. So this is 1, which means this can't be 1 here. One of these is a 1, which means this can't be 1 here, so this must be 1 here. One of these is a 1. This cannot be 1 because we know we have a guaranteed 1 here, which eliminates one possibility from being there. So 1 has to be here, which means in box 8 or column 6, where's the 1? Can't be here because of 1 in the row. It has to be one of these two, which is not on an arrow. So therefore 1 has to appear on an arrow in the rest of the boxes. So this is 1 here. That means these can't be 1 here. So this has to be 1 there, which means this can't be 1 there. So this is 1 there. Whoops. Remove the coloring. So this can't be 1 here, which means that's 1 there. And now we can proceed with the rest of the puzzle. Now that the challenge mode is done. So this is 1, which is consecutive with 2 only. This is 1 and 2. So this adds up to 16. So it could be 7 and 9, or it could be 8 and 8. We don't know which. This adds up to 16 without 1, 2, or 9. This can't be 2. So this has to be at least 3. So we have 1, 3, and potentially 1, 2, which adds up to at minimum 7. So this has to be 6, 7, or 8 here. This cannot be 2 here, so this is at minimum 3. So then this is minimum 2 here. This is actually 2, 3 at least. This is 2. You cannot have a 1 here. So this is 7, 8, and 9 here. That means it could be, we have 2. These add up to 7 at most. So it could be 2, 5. Or 3, 4, possibly. Or 2, 4. You cannot have a 5 here, though, because that would be 3, 5, 1, and 1, adding up to that. This digit is at least 2 and 3 added up to... We need a 2. Well, not necessarily. These digits, then, are... What are the max these can be? You have at least 1 and 3 here, so that's 4. Therefore, this must add up to 5 at most. So this must be 2, 3, or 4. This is 1 and 2 at minimum. That means this adds up to 6 at most, so this is 3, 4, or 5. To add up to 8 here, it's either 2, 6, or 3, 5 here. To add up to these, it has to be 2, 3, and 4, because this is minimum 3 here. This can be 8 at most here. This cannot contain... Okay, so again, this has to have 16, and it cannot be 1 and 2 or 9 involved. These have to be... So we have adding up to 7 or 8 here. It's 2 through 5. This can't be 2. This can't be 2. This is at minimum 1, 3, and 4. So this 1, 3, 4 adds up to 8. Because 2 can't be here, 2 can't be here on this arrow. So this is minimum 1, 3, 4. This is 8, which means this can't be 8. So now it's a combination of 1, 2, and 1, 2, or 1, 2, and 1, 3. Either way, this is 2 or 3. 3 has to be in a 1-2 ratio with 6. 2 can be in a 1-2 ratio with 4 or 1. But this can't be 1, so this is 4 or 6 there. If this were 3, that would force this to be 2 and this to be 4, but then the 3 and 4 would eliminate all possibilities for that cell there. And this is guaranteed to have a 2 here on this arrow because you can't have 3 and 4 remaining. And if you have tried to add 1, 5, and 6 together, they don't add up to a single digit. So this must be 2 here, and we have 5 or 6 here. Again, this can't be 3 because that forces this to be 2, because that would have to be 7 at most. And then 2 and 4 would be here, but 3 and 4 would eliminate all possibilities for that cell, so this can't be 3, this is 2. This can no longer be 2, so this can't be 6 there. Okay. This adds up to 16 without 8, 9, 1, or 2 for 3 digits. So what does it have to be then? So remaining digits in column 8 are 3 through 7. You could have 3, 6, 7. Or 4, 5, 7. If you don't have a 7 here, the most you can be is 4, 5, and 6, which doesn't work. So we're guaranteed a 7 here. We guarantee this is either 3, 6, 7, or 4, 5, 7. So the 3 or 4 is here, which means this can't be 3 or 4. That means this can't be 3 or 4. This can't be 7, so this is 5, 6 as a pair, which eliminates 5, 6 in the rest of the row. This can't be 6, this is 7, 8 as a pair then here. So this can no longer add up to 5 because, or cannot have 1, 5 there because that adds up to 6 plus 3, which adds up to 9. No 4 here for the same reasoning. We have a 2, 3 as a possibility for one of these 2 digits, and this is 2 or 3 left. Because this is at minimum 1 and 3. So 2, 3, and 2, 3 eliminate 2, 3 in the rest of the column. So this can't be 3. You cannot have... Well, this can't be 8 because of 8 in the row. And this can no longer be 1, 2, 3, 1, 1 with 2 and 3 here, which adds up to 7. So this must add up to 9. Therefore, these must be adding up to 7 here, because we have 1 here and 1 here. Well, this can't be 3 and 4 because of the 3, 4 pair in the... That would eliminate all possibilities for this cell here. So therefore, this must be 2 and 5, which means this can't be 3, 5. So it must be 2 and 6, which means this can't be 2. It's 3. So we have 1 and 3 here, and then this must be 3 and 1 to add up to 8, which makes that 8. That's 7. These digits... Okay, so remaining digits in column 2 are 4 and 8. This can't be 8 because of 8 in the box, so this is 4. This is 8. This is either 3, 6, 7 or 4, 5, 7. And this is 4 or 6, which eliminates 4 and 6 in the rest of the box. So then this cannot be 7 or 4 or 6 or 1 or 2. So we have 3, 5 with 8 and 9 here. No 8 here because of 8 in the row. If this is 2, then this becomes 6. If this is 3, this has to be 6, which forces that to be 7. So either way, this can never be 6 here. Interesting. 8 and 9 have to be here. This must be an 8-9 pair here, then. Remaining digits in row 6, we have 4, 5, 6, 7. And this can't be 5 because of 5 in the box. Remaining digits in box 4 are 4, 6, 7, 8. No 8 there because of 8 in the column. This is 4, 6, 7, 8. If this is 4, this cannot be 3 because that would eliminate all possibilities for that cell. So if this is 4, that's 5. If this is 6, this is 5 or 7. It cannot be 5 here if that's 6, but it could be 7 here still. 7 and 6 is possible. 8 with 7. 7 with 8 is possible. And 8 cannot be with 9 here. So remaining digits in row 5 are 3 through 8. This cannot be 8, and it can't be 7, 5, or 6, because this is a 5, 6 pair here. This has to be 3, 4, or 7, which eliminates 3, 4, and 7 in the rest of the column, because of the 8, 9 pair and the 5, 6 pair in the box. So this is 5, 8, and 9, which eliminates 5 here. That's 6, 2, and 1. Adding up to 9, which makes that 8. No 6 here, no 4 here because of the 3, 4 pair in the box and the 6 in the box. That leaves this as a 5, 7 pair in box 6, which eliminates 5 and 7 in the rest of the box, or rest of the column. 5 eliminates 5 here, so this is 7, which makes this 5. That makes this 6, which makes that 5. This can no longer, 6 eliminates 6 here, so that's 4, which is in a 1 to 2 ratio with 2. This cannot be 4, 5, and 7. It's 3, 7, and 6. 4 eliminates 4 here, so that's 3, which makes this 4. 5 eliminates 5 in the rest of the row, so does 4 and 7, which means this can't be 4 or 7. It's 6. This can't be 6. It's 8. That means this can't be 6 here. This can't be 6 or 8. It's 4 or 7. 4 would be consecutive with 5 here. 7 would be consecutive with 8 here because we can't have 6 in the row. No 3 or 6. Remaining digits of row 4 are 3 and 9. 4 eliminates 4 here. This can't be 7 because of 7 in the row. This can't be 3 because of 3 in the row. This is at minimum 2 and 3, adding up to 5, but it cannot be 5, 6, 7, or 8, so this must add up to 9 here. And this is either 2, 7, 3, 6, or 4, 5. No 5, 6, or 7 here, so no 2, 3, or 4 there. Okay. These digits add up to 16 without a 9, without 1. Can you have 2 here? 2, 6, and 8 is potentially possible. What are these digits? It has to be 2, 4, 5, 6, 7. Okay. Huh. Remaining digits of row 9 are 2, 3, 4. This cannot be 3 or 4 because of 3, 4 in the box. So this is 2, which means this can't be 2 here. This can't be 7 here. This must be 3 and 6 or 4 and 5. This digit cannot have a 3. Okay, that doesn't tell us too much. Remaining digits of box 7, we have 5, 6, and 9. No 6 here because of 6 in the column. No 9 here because of 9 in the row. We have a 5, 6 pair in row 8, which eliminates 5, 6 in the rest of the row. So that leaves the remaining digits as 3, 7, and 8 in row 8. Okay. Remaining digits of column 1, we have 3, 4, 5, 7, 9. No 4 here because of 4 in the row. Remaining digits of row 3, we have 3, 5, 6, 7, 9. No 9 here because of 9 in the column. If this is 3, this can't be 2, so that would be 4. If this is 5, this could be 4, but it can't be 6 because of 6 in the row. If this is 6, it could be 5, 7. If it's 7, it has to be 8 here. Okay. Okay, remaining digits of column 3. We have 4, 5, 6, 7, 9. No 6 here, obviously, because of 6 in the box. Row 7, we have 2, 4, 5, 6, 7, 9. No 9 here, obviously, because of 9 in the box. No 2 here because of 2 in the column. No 2 here because of 2 in the column. So where's the 2? It has to be here. So this is 2 here, which means this adds up to 14 for the two remaining digits in the cage. And it can't have a 9 there. So therefore, it must be 6 and 8. Which means this can't be 8. It's 5, which is consecutive with 4. 4 eliminates 4 here, so it's 7. There's no 7 here then in column 1. No 4 here because of 4 in the column. No 4, 5, or 8 here. It's 7, which means this can't be 6 or 7. It's 4. No 4 or 7 here. It's 5, 6 as a pair, which eliminates 5 and 6 in the rest of the box. So this can't be 5 anymore. We can still have 3 and 4. We could have 6, 7, or 7, 8. 6 and 8. 8 eliminates 8 here. 6 eliminates 6 here. Okay. Remaining digits in column 6 are 3, 8, and 9. And we're guaranteed one of these two is an 8. Oh yeah, where it is 8 in row 8, it has to be here. This can no longer be 8, which means this cannot be 7 because we have a 4, 7 pair in the column. That leaves 3 and 6 remaining in column 4, and this 6 eliminates 6 here. So that's 3, which makes this 6 and 7 to add up to be consecutive. That means this can't be 7, it's 4, which means this can't be 4. It's 3 and 6 adding up to 9. 3 eliminates 3 here, so it's 7. 6 eliminates 6 here, so it's 5. It also eliminates 6 here, so that's 5. 5 eliminates 5 here, so it's 9, which makes that 6. 4 eliminates 4 here, so it's 7, which makes that 3, which makes that 4. 3 here eliminates 3 here, so that's 9 and 3, which means this cannot be 3 here. It's 8, 9 as a pair. This can't be 3, 9, or 7, so that leaves that as a 5, which leaves a 4 remaining in column 5. No more 5 here, means this is 9, which means this can't be 5 or 9. It's 3, which leaves this as 7, 3 here. No 9 here. 7 can't be here. This can't be 3 here, and it cannot be 9 because of 9 in the column. So this is 4, 5 as a pair, which eliminates 4 and 5 in the rest of the box. This can't be 5. That's 9. This can't be 5 or 9. It's 7. So 9 eliminates 9 here, so it's 8 and 9. 8 eliminates 8 here, so it's 5 and 8. And 5 eliminates 5 here, so that's 4 and 5. And that's how you solve it. Yeah, I'll put the video, I'll put both the possibilities of the challenge mode and the non-challenge mode in the description. Because some people might not want to go through this path of actually going through the one, all but one. And that's perfectly fine. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.